one of the things I was studying in graduate school was variable stars. And so let me say something about that because it kind of fits in when we're talking about these other things about stars. Uh, a lot of textbooks typically put the idea about variable stars elsewhere, but I like to put them here. Uh, Variable stars are stars, as the name implies, vary. Well, they don't just vary, everything varies. But these are stars that vary in luminosity or vary in brightness. So all stars actually turn out to get brighter and dimmer a little bit, even the sun by a tiny little bit. But so variable stars are stars that vary significantly. Now, unfortunately, there's no real definition of what significant variation is. So people kind of argue somewhat about some stars as to whether they should really count as variables or not. Stellar variation can be either intrinsic or extrinsic. Extrinsic means something outside is making the light change. Intrinsic means the star itself is changing. Variable stars were actually known since ancient times. And there's some indication that some of the ancients noticed that the star Algol varied. Algol was known as the demon star, Al Rash Al Ghul, the head of the demon. And so about every 3 days or 2.9 days, it gets dim. And to the ancients, going from being a fairly bright star in a constellation, the second brightest in the constellation, to being like the fourth or fifth brightest was an evil omen. It meant something bad was happening. And so Algol was bad. There's another star, Omicron Ceti, that on the other hand was normally too dim to be seen with the naked eye, but then appears now and then. And so apparently a star appearing was a good omen because it was known as the Wonderful. Okay. And so Myra is the name of it. Well, the idea that stars vary were kind of lost in time until 1596, and a fellow named David Fabricius is making maps of the sky, and he's kind of checking his work, and he maps Cetus, and there's a star there, and then the star's gone next time he looks, and then it's back again, and then it's gone, and then it's back again. And he realized it was a star that was getting brighter and dimmer, and it was sometimes bright enough to be seen with the naked eye, and sometimes it was too dim to be seen with the naked eye. And so that's the star that we now refer to with the Bayer designation of Omicron Ceti, or it's also called Myra, is the proper name of it. A fellow named Montanari then rediscovers that Algol is variable, and this is some decades later, and then like a century goes by, and then a fellow named John Goodrich discovers that Delta Cephei is a variable star. And it's not real clear why no one really noticed up to this point how stars varied, or maybe it was about this time that they were starting to really seriously measure magnitudes, or when they got a magnitude that was off, they just didn't believe it, or what have you. Today we have about 500,000 known variable stars, and more being discovered all the time. That 500,000 that we know, and then probably about another 500,000 that someone has reported as variable that we're still trying to assess. So the way you describe a variable star is with a light curve. So you graph magnitude versus time. Okay. And this particular star is Delta Cephei, and it gets bright really quickly, slowly gets dim, gets bright really quickly, slowly gets dim. So you can measure from peak to peak or trough to trough or what have you. And that is the period, the time it takes to go through one complete cycle. So how do you name a variable star? A lot of these variable stars are dim and they don't have proper names. And so Argelander, Frederick Argelander, was, of course, working on other sort of things, but the Bonus Muxrum, for example. But he came up with the idea of giving a designation to variable stars. And so what he did was he decided to use letters. Okay, now the Bayer designation uses Greek letters, so he's going to use Latin letters. So instead of alpha, beta, gamma, it would be A, B, C, D. Okay. But to avoid confusion, he started way down the alphabet. He started at R. And so it's R, S, T, and so forth. So R is the very first variable star discovered in a constellation. S would be the second variable star discovered in that same constellation. And T would be the third variable star discovered in that constellation. For example, R Leo is the first variable star in Leo. And then the first variable star in Sagittarius would be R Sagittaria. The second would be S Sagittaria. So U Sagittarii would be the fourth variable star in Sagittarius. T Tauri, the very first variable star in Taurus is R Tauri. Then S Tauri would be the second. So T Tauri is the third variable star. And if you have 8 variable stars in constellation, like in Cepheus, Y Cephei would be the 8th one. Now, the problem is, this is only 9 possibilities per constellation. Now, Archelander thought this was very generous. Because after all, there were 88 constellations, and at the time, there were only a handful of variable stars that were known. I think only one constellation had more than one variable star. And so you had R and S. And so his system allowed you to have up to 9 possible names in a constellation. And so this worked well for a number of years, but as astronomy progressed, we eventually found a constellation with 10 variable stars in it. So what do you do when you go past Z? Well, so you go back and you double up. So RR Lyrae would be the 10th variable star in the constellation Lyrae. And the 11th is RS, the 12th is RT. So RT Corvi is the 12th variable star in Corvus. RT Lyrae would be the 12th variable star in Lyra. So you go all the way up to RZ, and this gives you another 9 possible names. So now you have 18 possible names in a constellation. Okay. That seemed plenty sufficient. Well, astronomy kept progressing, kept finding more variable stars, and eventually found a variable star with 19. Or a constellation with 19 variable stars. So what do? Well, you could go back and do another R and go RRR, but then you don't want to do that because then people think you're a pirate. RRR. Okay, so what do? Well, what they did was they said, well, instead of going back to R, we'll do S and do SS and go SS to Z. So we do SS to SZ. Okay, and that gives you another 8 possibilities. And then TT to TZ, and then UU to UZ, VV to VZ, WW to WZ, and then XX to XZ, keep going till you get to ZZ. And of course, that's going to be ZZ top. Okay, anyway. All right, so what do? This gives you a whole bunch more possibilities, obviously. It gives you 54 possible variable star names in each constellation. Again, that seemed very, very generous. Remember, it was 88 constellations? 54 variable star names in a constellation. It's only a few thousand. And yet we have hundreds of thousands of variable stars. So it's no great, stretch to imagine that eventually they found a constellation with 55 variable stars in it. So what do? Well, they went back to the beginning of the alphabet, AA to AZ, and skipping the letter J because I's and J's are interchangeable in some countries. So to make this international, then we don't want to have both I's and J's in our system. And so we skip the letter J. So we skip J. And so AA to AZ, that gives us a whole bunch more variables. Okay, except that wasn't enough. So BB to BZ, CC to CZ, QQ to QZ. At that point, we now have 334 possible letter combinations per constellation. With 88 constellations, that makes over 29,000 possible variable star names. Nowhere near enough. So we got to have some other way of doing this. Okay. Well, there's another way. Finally, Charles Andre. About the time that Argelander was doing his thing, proposed, why don't we just name them V1, V2, V3, and V4 in order of discovery. Okay. Now, the problem is that Argelander's method is what everybody did, but this way there's no N. So you could actually have a V1200 Cygni. That'd be the 1200th variable star in the constellation Cygnus. And that actually is a variable star name right there. Okay. So what they did was they went ahead and decided to use the Argelander system for the first 334 variable stars. So that's going to be the letters and the constellation name. And then you're going to pick up as the V335 and the constellation name from there on. And so this is how we decided that we're going to do this. Well, we didn't decide. It was decided long before I came along. And so this is how it is done. And so these are the variable star names and how the variable stars are designated in a constellation. So if you look at a star map and you see something labeled V421, then that is a variable star name. If you see a star labeled AR something, on a star chart, that's a constellation. So V421 CNC Cancri. Okay, so that would be a variable star name, or AR Orionis. So then that's a variable star name right there. So this would be in the constellation Orion, and that'd be in the constellation Cancer. Turns out, with so many variable stars that are out there, there's a lot more need to study variable stars than there are astronomers to study variable stars. And this is an interesting thing. There's way more variable stars than professional astronomers. Professional astronomers don't have time to study them all. But one of the most important things you need to do is just sit and measure how bright it is. And you don't need to be a professional to do that. And in fact, a lot of professional astronomers are under pressure at universities to publish results really, really quickly in order to keep their jobs. And so variable star work sometimes takes years. And so amateur astronomers really help the professional astronomers. So there's actually an organization, the American Association of Variable Star Observers, that has both amateur astronomers and professional astronomers in it. And so the amateurs can go out there and they're not under time constraint. They just, when they get a chance, they look at a handful of variable stars and record how bright they are and submit the data. So a professional astronomer could then come back later and say, I need 60 years worth of data on a particular star. Well, no one person has been watching it for 60 years, but a whole bunch of people have been watching it. And so then you can collect data and archive it and publish data about stars. And so this is actually how a lot